Okay, I might talk quickly because I want to try to wrap everything up in this last video. So how do we determine the p-value with a two-sided alternative hypothesis? So the steps are the same, no matter what the problem. So if you know you have a two-sided alternative hypothesis, here's what you do. You compute your test statistic as normal using that z-statistic formula. You then go to table B as normal. So if the test statistic ends up being negative, you go to table B, you find the percentage below the test statistic. If it's a positive test statistic, you want to go to table B and then you find the percentage above the test statistic. So if it's positive, you know that you'd go to your table, you'd look at the percentage there, and you'd need to subtract that by 100 to get that area that's falling in the upper tail of the distribution. So here you're going to end up with a percentage, either a lower tail percentage or an upper tail percentage. So you're going to get one number here based on whether you have a positive or a negative z-score. And then you take whatever number you get there, you multiply it by 2. That's your p-value. That's your final p-value. And then you're going to go back and you're going to compare that p-value to whatever alpha is. Okay, so you get a p-value from the table as you normally would, and then the extra step is that you're going to have to subtract that answer from, or you're going to have to, multiply that by 2 to get your final p-value. So let's practice this. CPR and on pets. So there was a national survey conducted in 2009, and they made this claim that 58% of pet owners perform CPR on their pets. So they're making a claim about what they feel is going on in the population. Now, let's say that you believe that claim is wrong. What you believe is that a different percentage of pet owners would actually do this. We're not saying that you think more or less than 58% would do this. You just think something different is going on. This is really the key word here to clue you into the fact that you need to do a two-sided or two-tailed test. You need to have a two-sided or two-tailed alternative hypothesis. You obtain a random sample of 1,116 pet owners, so that's your N. What would our hypotheses be? What are you thinking they would be here? So hopefully you're seeing we're going to be dealing with a proportion where basically each individual is basically just giving us a yes-no answer. Yes, I would perform CPR, no, I would not. So in the end, we have proportions or categorical data. The claim is that the population proportion would be 0.58, so we need to convert this back to a proportion. The alternative would be that it's not 0.58. This is where we'd have that not equal sign as our sign in our alternative. From our sample, we obtain a sample proportion, a p hat of 0.56. What would the sampling distribution look like? Where would it be centered? What would the standard deviation be? So I've drawn it here. I know that it's very small here. But to find the standard deviation, remember we'd have to take p times 1 minus p divided by n. Now when I figured this out, I got approximately 0.015. And I'm not quite sure why I didn't round up to 0.02 to make things easier on myself, but I kept it as 0.015. And then I drew this out. So where's 0.56? 0.56 is going to be over here someplace, right? So this is where our actual sample proportion is falling. And again, this distribution is centered at 0.58, or the population proportion. So I want to see what my p-value is going to end up being. So how am I going to conduct this test? So what is the test statistic? So again, z equals p hat 0.56 minus 0.58, which is p, divided by the standard deviation of the sampling distribution, which I just told you is 0.015. And of course I didn't figure this out. Let me quickly figure this out. Okay, so I'm getting about negative 1.3. So again, please double check my work so we can make sure that we're all getting the right thing and there are no mistakes. Okay, So I double checked. I think I got the right thing here. What's the p-value going to be? So do I have the table here? So I got negative 1.3. I'm going to go to the table. Negative 1.3, 9.68%. Remember I told you if you get a negative value for z and you go to the table and you look up a percentage, you're just going to take that number because we're looking in the lower tail and you're going to multiply it by 2. So 2 times 9.68% is going to give us what? Oops. So 2 times 9.68 will give us 19.36%, and we know, again, we want to divide that by 100% to get a probability. So the p-value here is 0.1936. So let's go back to our other slide. The p equals 0.1936, our p-value. If we're assuming, again, an alpha level of 0.05, p in this case is greater than 0.05, or 0.1936 is obviously much larger than 0.05. Another way of thinking about that is 19.36% is clearly much larger than 5%. What will our decision be? Fail to reject the null. So we do not have enough evidence in this case against the null hypothesis. We do not have enough evidence in this case against the claim that individuals in the population, or 58% of individuals in the population would give CPR to their pets. Okay, I have another example here that I thought we would look at quickly. So male drivers lost longer than women. So I thought this was an interesting study. I saw this and they made some claims that I thought were interesting. So the article states that the average male drives an extra 276 minutes every year as a result of being lost, the equivalent to a journey from Cincinnati to Nashville. So let's say you believe this is false. You believe the average male spends a different amount of time than 276 minutes driving around while being lost. So to test your theory, you obtain a sample from 40 male drivers. You find that they have a sample mean of 250 and they have a sample standard deviation of 49. So I want you to think here about how you would conduct a hypothesis. I want you to pause the video. I want you to try to actually conduct your hypothesis test before coming and seeing what I do. Think about what your null and alternative would have to be. Think about what your test statistic would be, what the sampling distribution would look like, how you would obtain your p-value from table B. So pause quickly and then we'll come back and work through this. Okay, so hopefully this is what you wrote down for your hypotheses, that the claim is that the population mean is 276. Hopefully it's clear to you why we're dealing with means here and not proportions. The alternative is we think something different is going on. We think the mean is something different from 276. What would the sampling distribution look like? So to figure that out, we know we'd have a normal distribution because we have a large enough sample size, centered at 276, the claim about the population mean. And if we figure out the standard deviation divided by the square root of n, so here we have 49 divided by the square root of 40, and I rounded this to approximately 8. So here I rounded a little bit just to make my calculations easier. And now we have to figure out our test statistic. So z equals our sample mean, which was 250, oops, sorry about that, 250 minus 276 divided by 8, which is going to give us negative 3.3. Now we have to find our p-value. So what do? Again, we have a two-tailed alternative. We go to the table, negative 3.3. We get 0.05. Because we have a negative z, we take this number, multiply it by 2. That's going to give us 0.10%. We divide 0.10 by 100 to get 0.01%, or 0.01, not a percent. So our p-value, our probability is 0.01. We go back here, so p equals 0.01. 0.01 is less than 0.05. we are going to reject the null hypothesis. So we have evidence within our sample that the population mean is something different from 276. Okay, so again, this could be true, it could not be, we can't say for sure. We're saying we have evidence in our sample that something different is going on, that claim, we have evidence against that initial claim. Now, one thing you can do here, so you have evidence against the claim, you have evidence that maybe this is not the true population mean. Well, what might the true population mean be? How might we estimate that? Hopefully you're thinking about the fact that, hey, we could construct a confidence interval. So we can take our sample data and construct a confidence interval now. How would we do that? Well, remember this formula. So we have all the information where we could easily just plug numbers in and construct a confidence interval. And sometimes a hypothesis test will be followed up with that. If you reject the null and you want to try to estimate what's actually going on in the population, you can do that with the confidence interval. So if we plug everything in here, we get 250 plus or minus. Z star is going to be 1.96 because we're assuming we're using 95% confidence. And you'll see that relates to using an alpha level of 0.05 or 5%. And then we take 49 divided by the square root of 40. If you figure that out, you end up getting 250 plus or minus about 15.68. That gives you two numbers, 234.32 and 265.68. Again, please check my work. But how could we interpret this confidence interval? So how could we write a sentence, a confidence statement? I'm 95% confident that the interval from 234.32 minutes to 265.68 minutes includes the true mean number of minutes a male driver would drive around while being lost. So we could say something like that. We're 95% confident that this interval is going to include the true population parameter. And in this case, that true population parameter is a population mean. So I'm going to wrap this up now for chapter 22. I hope this gives you a good sense of how to move forward with homework related to this chapter. And you'll see problems like this on the final. So we hope this will help you and will help you with other activities and assignments in the course. As always, please ask us questions so that we can try to help you further. Thanks, everyone.